Number 7 we want to talk about is XSS, and that stands for cross-site scripting. This is another sort of scary sounding one. It's also a really prevalent vulnerability, and its impact can range wildly from really minor to critical, to complete server or network takeover. It just depends, and there's a lot of different ways it can be exploited, so this is a big one. This is actually a type of code injection vulnerability, number 1. Number 2, it's it's when user-supplied data becomes executed as code within the web browser. So primarily, we're talking about JavaScript, because JavaScript can be used to do just about anything on a computer these days. If an attacker is able to find a way to get another user's browser to run specific JavaScript code, they can make that user's browser do anything that the user can do. There are 2 main methods for doing XSS attacks. Number 1 is reflected. This kind of XSS happens when unvalidated or unescaped user input becomes part of the HTML output. What I mean is, like, when you do a search, say a Google search or something, in this example, there's an article search, and it has a field that says enter your search terms, and in the screenshot I entered beer and click submit. I would just get, in the output, basically it's going to say, here are your search results for insert whatever the user put in the text box here. So it'll say, here are your search results for beer, and then display the results. The problem with this is, if that input isn't validated and checked properly, an attacker could put something like this interesting input into that field. And if you know JavaScript, you know that if you just insert this into the HTML of a document, will display an alert to the user. And in this case, since I'm doing a search on a web page, it's on my web browser on my computer, all I'm doing is attacking myself here. So it displays an alert for me. But the point is that what this proves is if that malicious input with the script tag is accepted and displayed in the HTML output, that web app is vulnerable to XSS attacks, and the attacker could do all kinds of other things once they know that that's not validated at all. So here's an example of what I mean by when you get the HTML response with the search term in there. So beer just gets put in there as plain text search result for beer in the results, and that's just an excerpt. So below that, you would actually see the search results from the server. But in a malicious HTML input like the script tag, the HTML output would include the script tag just concatenated into the HTML, which is really bad, because then this would be ran by your browser and display an alert. The alert just says hi, but this proves that, like I said, JavaScript can be run reflected back from the server to the user, and that shouldn't be possible. Talking about number 2, the second method of XSS attack is stored XSS. This is the worst one. It's when an app stores unsanitized user input that's viewed later by another user or admin. For example, you might have a blog website where you have a form where you allow users to leave a comment. In the case of an attacker putting in malicious input, they might put a script in there, just like I did on the previous slide in a search field, except this time it's going into a comment on a blog site. So what this does is after you click post comment, it inserts that straight into the database with no input validation. So later on when a user or say an admin or somebody views that comment or just views the blog post, if it includes comments at the bottom, every user that tries to visit that blog site and view that comment on the page is going to get a pop-up that says hi. And now the alert, like I said, is really harmless. It's just an example, but it proves that if you're able to do this, you could insert all kinds of malicious scripts into that backend database, which would cause the users viewing that later on to run that script in their browsers automatically. And you could exfiltrate all kinds of data or take over their system potentially. So it's a really bad attack vector. And like I said, it's the most dangerous type of XSS. So the impact, endless possibilities. The attacker can do anything the target can do from their browser because they're able to execute JavaScript code in end users' browsers. It's that simple. They could use it to steal credentials, hijack users' account, deliver malware to the system. Endless possibilities. Other attacks include key logging. So they might just want to record the keys in the background quietly that the user's typing on, say, their bank site when they're logging in, or just harvest some personal data from the user to use for identity theft, or break into another account. So here's an example that I found from the news pretty recently. So this was only a month ago, but this displays how prevalent these kinds of attacks are. This Roundcube is a webmail software provider, and it's open source, but they apparently found an XSS vulnerability that opens up the door for attackers to take over any email account they want to using the service. So that was already patched and fixed, but it was just a really simple XSS vulnerability, and it was caused by just failure to sanitize user input. So, and I believe specifically it was user input in the email messages that are sent and received by the webmail server. So users that used it were potentially vulnerable to account takeover. And the method used was stored XSS. For preventing XSS, you want to use a framework that just does the escaping and encoding for you safely automatically. There are many out there, and this is by no means a fully inclusive list. These are just really common frameworks out there. One is React.js, there's Django. I think Django's PHP based, I could be wrong. Then there's ASP.NET. These all do a large amount of escaping and encoding for you to protect you from these kinds of attacks. So if you're using one of those frameworks for your app, you're protected from a lot of this already. But it is still possible. You still want to validate all user-controlled input as much as you can. And also remember to encode properly before displaying data in the web browser. And you have to use encoding appropriate for the context. So that's another reason why XSS is so prevalent, because there's a lot of different types of encoding out there. If you're displaying simple HTML in a web browser, you need to use HTML encoding. If you're putting user input into an attribute value of an HTML tag, you need to use attribute encoding. If you're inserting user-controlled input into a JavaScript tag, use JavaScript encoding and CSS encoding for CSS from user input, and of course URL encoding if user input is being put into a URL. Also, this one I won't go into more detail of, but you could read more about it in the prevention cheat sheets here, but there's a special cookie flag that you can set if you have to store anything in cookies for your users. Use the HTTP only cookie flag. Another best practice to prevent XSS is use CSP, which is Content Security Policy. And that, for CSP, I could really go into a talk 4 to 6 hours about just that alone. So there's a lot to it, but it's one of the best methods we have of preventing XSS attacks currently. So if you have a web app, you definitely want to reference the cheat sheets about that. Reference OWASP, XSS prevention cheat sheet, and it'll talk a lot about CSP. And there's a specific CSP cheat sheet.